Welcome, this is the 2.6 Ready, Set, Go homework solutions. Alright, we have the ready part here. It says compare different characteristics of each type of functions by filling in the cell of each table as completely as possible. Alright, so the first one, we have the equation. You have it as y equals 4 plus 3x. This is weird because you see it as y equals mx plus b, so I just rewrote it, just did some commutative property, wrote it as y equals 3x plus 4. Next, you have a y equals 4, 3 to the power of x. Alright, on the left hand side, we saw that this is a linear equation, so there is a constant slope. Then on the right hand side, this is a exponential equation, therefore it has an exponential growth. The growth is not constant. What sort of sequence is that? This is an arithmetic sequence because it's a linear equation here. And this is a geometric sequence because it is an exponential. Next, I computed some values. I started with the 0 term. I plugged it in, got the y value. Compute 0, 1, 2, 3, and 4. Once I did that, I was able to find the slope for the rate of change. For this one, it is just what is in front of the x, which is 3. For this one, I am looking right here for the r, which is the um, common ratio. So here in this case it was 3, so I wrote 3 here, or you could think about that as a growth rate of 300%. Graphing the equation, okay, that's how it looks like in Desmos. This is the linear equation of y equals 3x plus 4, and here the graphing of y equals 4, 3 to the power of x. Notice that both of them have a intercept of y, okay? That is something that they will have that in common. That is something that they have that is the same, which is they have the intercept or y-intercept of 4. What is different is that this is linear and this is exponential. Alright, next, that's what 6 is. It just asks for what is the y-intercept. Notice all of them is 0, 4 because the y-intercept is a point. That's why I wrote it as an ordered pair. Okay. Next it says find the y-intercept of the following equations. Y equals 3x, so I see that as y equals mx plus b. There's no b term here, so the y-intercept is actually 0. Y equals 3x. Okay, I notice that the y-intercept here is 1 because what is out in front here is a 1, right? That is what the 0 term is, the f of 0. So explain how you find the x-intercept of a linear equation and how finding that is different from the y-intercept of the geometric sequence. Right, so here I drew it out for you and it's also in green. It says y equals 3x plus what it's supposed to add is the y-intercept here. Notice that there's nothing here. That's why the x-intercept here it's 0. Right here, likewise, it's y equals, this is the first term, right, the 0 term, f of 0, that is the y-intercept, okay? Here, it's a 1, right, because it can't be 0, because 0 times anything is 0, right? So that is a 1 right there. Good. Right, that is the ready part done. Right, here's the set part. For each exercise or problem below, use the given information to determine which of the forms will be the most efficient to use for what is needed. Okay. All right. So we have this scenario. You can read this for yourself. Some important information. It says that she deposits $175 a month consistently. That consistently means it's a constant slope. Her last statement shows that it's been open for 10 months and she has a balance of $2,475. Which equation form did I use for them? I used a linear equation because of the constant deposit. Here's writing the equation. I wrote as y equals $100, 175x plus something. I do not know this something because she does not remember how much she deposited. Okay. That's why it's something here. Alright, but I know that x equals to 10 because it says because the account has been open for 10 months. Because the account has been open for 10 months, I can substitute that in for x. That is how I got this equation. Okay, then you could solve for b from there. 10 Right, using the table below, show the numbers of rectangle created every single time there is a fold made through the center of a paper. Use the table for the equation. So I have the table there. The first one, find the numbers of rectangle created by 5 folds. I saw that this is growing exponentially with a common ratio of 2. So notice that the first fold is 2. That's why I'm going to use the first term exponential equation. Y equals f of the first term, which is 1, r to the power of x minus 1. I write the equation y equals 1 parentheses 2, right? And the 5, because it says 5 folds, that's why it's 5 here. 5 minus 1 is 4. Remember, this is the first term exponential equation, right? Simplify, putting that into your calculator, you get y equals 16 rectangles, and this is only for 5 folds, okay? Next, find the equation for create for 5 folds, okay? Oh, so sorry, for 15 folds now. No, 16 folds, right? Again, I'm using the first term. Plug it in, so it's to the power of 15 now, and I get 32,768 rectangles from 16 folds. 11. We have the scenario here. You can read it yourself. It says, I currently weigh 90 kilograms. I plan to lose 1.2 kilograms a week. The equation is going to be a linear equation, y equals mx plus b. But here, I saw that the slope, because it says it's a loss of 1.2 kilograms, so it's y equals minus 1.2x plus 90. The 90 comes from your starting value of your currently weighing. Next, 12. Here's the scenario. It says, I walk a little bit more each day. Walk a little bit more each day. This indicates that the slope is not constant. It's changing every single day because it says a little bit more each day. Okay, she decides to walk 10 meters more each day. So on day 20, she walks 800 meters. How many meters will she walk on day 21 or day 60? Which equation did she use? I used the zero term exponential equation. Here they would ask you to write the equation, but there's actually a problem here. You can't actually write the equation. The reason why is that the problem doesn't give you the f of 0, the zero term, or the f of 1, which is the first term. It doesn't work. So without that, this is the best I can do, right? This is the best I could do. On day 20, she walks 800 meters. 800 goes in for y. I know that my x is 20, but I don't know what my f of 0 is. It doesn't say what her what her first day she walked or her 0 day she walked. It's very difficult to get that. So, alright, and is that it for that one? We have 13 now. It says, for each equation provided states what information you need to see in the equation that will help you graph it. Then graph it. Also use the equation to fill in any 4 coordinates on the table. Here's the equation, y equals 8, 1/2 to the power n. I notice, I have it graphed. What I notice here is the y-intercept. I'm going to make that green. That is going to be 8, as well as the common ratio, which is going to be red, which is 1/2. There you go. Okay, that's how it looks like when it is graphed. Those are the 2 pieces of information that the equation provides for me to help me graph. 14. I have y equals 5 parentheses x minus 2 close parentheses minus 6. This is really complex, right? This looks like the point slope form. I distribute, get it into y equals mx plus b. Once it's in y equals mx plus b, makes my life so much easier. I found that the slope is 5 over 1. I know that my x-intercept here, y-intercept is negative 16. Y-intercept here is negative 16. Makes my life so much easier. So when I graph it, right, the y-intercept here is negative 16, and it's going up because the slope is 5. This is why the y equals mx plus b is such a beautiful form. It just gives you those. Okay. And, alright, here's the go part. Solve these one-step equation with some justifications. Okay, this is just a review of prior skills. Alright. Alright. 15. 2x equals 15, that's your original equation. Divide by 2, which is the multiplicative identity of equalities. 2 over 2 is 1, that's why you get your 1x. That is your multiplicative identity. 1x equals 15 over 2. 16. You have the original equation of x minus 10 equals to 2. Add 10 to both sides, that's the additive property of inequalities. Right? The negative 10 plus 10 here becomes 0. That's what happens when you simplify. The right hand side becomes 12 because 2 plus 10 equals to 12. The additive identity, because you no longer write the plus 0, you get x equals to 12. Let's do 17 now. Negative 16 equals x plus 11. That is the original equation. Subtract 11 on both sides. That's the additive property of inequalities. Plus 11 minus 11 gets you 0 after you simplify the left hand side. Negative 16 minus 11 gets you negative 27. The additive identity says negative 27 is now equal to x. 18, 6 plus x equals 10, which is the equation. Subtract 6 to both sides because that's the additive property of inequalities. On the left hand side, 6 minus 10 becomes 0. Bring down the x. On the right hand side, 10 minus 6 is 4. That's what happens when you simplify. Additive identity, just x equals to 4 because you no longer write that plus 0. Let's look at 19. 6x equals to 18. Multiplicative identity of inequalities, which is my divide by 6 to both sides, or multiply by 1/6, up to you. You get a 1x equals to 3 because 18 divided by 6 is 3. 20, negative 3x equals to 2. That's the original equation. Divide by negative 3 to both sides, or you could say multiply by 1 over negative 3 to both sides. That's your multiplicative identity of inequalities. My left hand side, negative 3 divided by negative 3 is 1. So I have 1x equals to 2 over negative 3. That is your answer. There you go. Those are your homework solutions.